Hello, my name is Fred Jensen. I'm the product manager for PowerLog, a geosoftware application. And today I'm going to talk about the value of integrating petrophysical interpretations with rock physics modeling. We're going to start off with the petrophysical interpretation. I'm running PowerLog, and I have StatMin running, which is an add-on module to PowerLog. It's the statistical package which computes lithology, porosity, water saturation, all the petrophysical parameters needed to do rock physics modeling. And I built what I consider is a pretty good model of the Deep Wilcox in South Texas. That's where the logs are from. And this is the zone that we're interested in modeling. So I've already built the model, and I've constructed a rock physics workflow. This is the starting point workflow, which actually is provided by PowerLog when you get PowerLog RPM. And I've included all of the curves I want to use, and I want to say that I've harmonized my rock physics model with my petrophysical model. My quartz density here matches, my clay density matches, and then all the inputs here are based on the outputs from the petrophysical model. So let's go ahead and run our rock physics modeling package and take a look at the curves that we generate. And we'll go through, and you can see we have a very good modeled acoustic, but our density curve is totally wrong in the clays, and it's a little bit wrong in the shalier part of the sands. So I suspect my V clay is incorrect, so let's go ahead and change our volume of clay. Let's increase it and run our petrophysical interpretation. You'll see we've increased our volume of clay. So we'll go ahead and run our rock physics model again with the different clay volume, and we'll see how that changes our results. And as you can see, it's gotten a lot closer, but we're not quite on. So let's change this to somewhere in between and rerun our StatMin. I may have added a little too much clay, so let's reduce it a little bit and go ahead and rerun our rock physics workflow and take a look at how we've done. So we'll watch. Now it looks like we've got a pretty good clay model. We could tune it a little further, but this is pretty good. The only place the density is different is in this zone with a lot of hydro gas, and I suspect this is a gas effect. We can prove that by going back into rock physics and doing fluid substitution, but that's not what we're covering here today. But what I was demonstrated here is the value of being able to adjust your petrophysical interpretation to see how it impacts your rock physics model. And in some ways, more importantly, I'm now able to say I've generated a valid V clay curve because it results in a good-looking synthetic density generated from rock physics modeling. So now I have a valid set of parameters that I can use to move into, say, if I want to go into quantitative interpretation or something like that. So what we've demonstrated today is the value of integrating your petrophysical interpretation with your rock physics workflow and generating a model that's consistent and harmonized. I thank you for your time and attention, and if you're going to get any more information about PowerLog and RPM, you're welcome to contact GeoSoftware at geosoftware.com. Thank you.